this video, I'm going to show you how to take this graph, this heating curve, okay, and I'm going to show you how to use it to find the latent heat. So that's a number, right? I'm going to close the door. People don't know how to act. It's okay. It's happening. There we go. All right, so the flat parts. Remember we said the flat parts. This flat part right here, and then this one, which I know is hard to see with the glare, right there. Those two flat parts represent a phase change. The temperature doesn't change. It stays flat, right? If the temperature doesn't change, and I ask you to find the Q, remember you can't use Q equals MCP delta T because there's no delta T. The delta T here is nothing. It's zero. It stays flat. So what do? Well, the heat is on the x-axis. So you go from this point to this point, you drop your lines down, and you see these two numbers. What do you do with them?
Subtract.
Subtract them. So 5.2 minus 1.0, I'm going to write this up here, maybe you'll be able to see it. 5.2 minus 1.0, that's equal to 4.2, and that would be joules, right? That's a heat value. This little flat line right here represents delta H fuse, because melting used to be called fusion. So the heat of fusion, the latent heat of fusion, is 4.2. You subtract these two values. You do exactly the same thing for the delta H vaporization. Okay? For delta H vaporization, this flat line where the temperature is not changing, that's delta H vap. The delta H vap is not equal to 6.9. And if I was going to ask you a tricky question on the test, one of the answer choices would be 6.9. The delta H vap is not 13.1. And I'm going to make that an answer choice on the test as well. What do you do with them? You subtract them. 13.1 minus 6.9, and it's what?
6.2.
6.2, and that's joules, right? Delta H vap is when you take these two, you drop your line down to the x-axis, and you subtract these two values from each other. That's how you get delta H vap. And remember, this is where potential energy is increasing, but not kinetic. Questions?
No.